Beleza, tranquilo. Okay, let's start. So in previous video I was studying about single linked list. Basically, single linked list is it's a structure that has data and a pointer. So data that we want to use and the pointer that is pointing to another node. So in the start we have the head and then we have something that represents a new object. I believe that today I'm gonna be studying about insertion. Let me see what it's important about the insertion. Okay. Okay, so basically the insertion process has the append method to insert the element, the data, into data structure. We can print list, it seems to be just a display of the data structure. Prepend, I don't know, but it seems to be appending before a node, I believe, and insert after node seems to be, like the name say, after a node. The append process seems to have two properties. We can append given that the linked list is empty and it's not empty. So I'm gonna try to think about this, and if I don't succeed, I'm gonna research more about it. Video size, I guess. So this was the implementation of the single linked list class. So we have the node here, we have the data and the pointer. Since when we are constructing empty linked list, the pointer points to a new object that in Python is none, and the single linked list has the head that points to none because it's an empty linked list. So let's think about this. Let's think about the append method. How can we append something in a linked list? I believe the pointer should be pointing to the in a linked list. If it's empty, you just point the head. You can just point the head to, I believe we can think like this. We have the head. The head is pointing to a new element, and when we append into an empty list, single linked list, me append into the list, the linked list. I believe we can just point it to the node. What's the reason about this? Okay. When we have not empty, it means that we have a node. Let me put some color here to represent this guy as something that is new to the. In this case, it's not empty. We have, for example, I'm gonna put 3 nodes here, and I believe that it's a good representation. And if I want to append something here, I need to traverse in single linked list. We need to traverse the list. So we start at the head. We go to this node here. If I want to place here, for example, I need to start here, traverse, and I need to remove this pointer from the to this node. So I think I'm gonna need something like this. Let me see how can I represent this. Okay, I'm gonna remove this guy. I'm gonna place a new node here. That's a blue node. This can represent a new node. So this guy should be removed, pointing to this guy, and this pointer should be pointing to this guy. Something like this. Okay. This is easier, and this is more difficult. Let me think about this. So how can we implement this in Python? I don't know. Let's think about this. So let's define this. I'm gonna create this method append, and I'm gonna pass the data itself. My computer has this crazy buggy. I never saw this in other computers. So if, for example, let me reason about this. I believe that if selfie hand is none, it means that it's an empty linked list. So if here we believe that, I believe that if not something like this, A is equal to none. If A exists, I believe print something A is not known. Let me check this. 3.8. Okay, there is no problem. So else print A is known. Okay, if this guy is not known, so if self head exists, we can how can I point to the loader, to a node, you know? Let me think about here. So I don't know, let's say self node is equal to node, I guess. Let's instantiate this class. And let me see if I can self node. I really don't know how to do this. I'm gonna ask ChatGPT. Okay, let's think about this. Singly linked list. How to point a node to another? I believe I can use next to node, but I'm not feeling comfortable with this, so. So I need to create the instance of the linked list. Okay. I create the node. I instantiate the node here with the data that we need. And okay, I'm pointing this to the object now. Officially setting the head of the list to node. I believe this come first. I don't know, but okay, it makes a lot of sense now. This was not making sense for me. Okay. So basically what we need to do is create the linked list. So I'm gonna call linked list, single linked list is equal to the instance that I create, the class, and I create this instance. Nice. And after creating the, let's remove here to help us memorize this process. So once they have the linked list, I should be pointing, for example, the attribute head to a node. Okay, but I don't have this node, and the first node is equal to the class node, and the class node needs a value, a data, when it's instantiated here. Let's see, it's number 1. Okay, so now this name, it's a bad name. I'm gonna call linked list like GPT. It's more intuitive. Okay, not defined. What's the problem here? Let me check this. Okay. So now I have a node. If I want to access the data from the node, I can access from data. I don't know where it's pointing. It's pointing to nothing. The non method. So if I print here, yes. Okay, and the linked list. I can print it's wrapping just the memory object, I guess. I think you can try to create the head, and it should probably be the node. Okay, yes. So the head is pointing to the node. Nice. So now if I want to append, let's start trying to append something here. So if the head is not known, it means that, okay, here is that this is how we append data to a empty linked list. So this is basically what I need to do, but let me think here. So instead of doing this, the linked list should append data, for example, 1. It should be appending a node, I guess, maybe. Instead of data, you know. I am in doubt here if I need to append data or the node itself. For me, it makes sense to make more sense. So if this guy is not none, for example, the linked list head, the self.head should be pointing to the node itself. So I believe that it's better press node here. I don't know if this is right or wrong, but I think passing the node, it's more it's the best, the better way to do this. And I need to instantiate node before this one, or I can simply pass in the sky like this, you know. So let's run this again. Restart, run all, and the linked list head is pointing to the object. Okay, it seems to be working. Let's try something here. For example, I can't access the node itself from the linked list, I guess. Maybe I can create a node here to access the node. And self.node is equal to node. Okay. I don't know if this is correct. I'm gonna test here again because I want to access the data, the node itself. And let me check this. Linked list, no. It seems that I am accessing the node, and maybe I can access the node data like this. Oh, nice. So the linked list node data. Uh, this seems to work. Let me see with ChatGPT how we can append. So how can I append a node to the linked list? For now, suppose now restrict to empty singly linked list. How can I append a node to the linked list? For now, restrict the problem. I'm gonna change this. How can I append a node to an empty single linked list? Let me see what it tells me terms about this and compare to what I did. Okay, let's see. Okay, check if list is empty. I'm doing this. Find the last node. I didn't think about this. If the list is not empty, I should traverse. Okay, I'm not thinking about this now. Append a new node. Set next. Okay. Append a new node. Set the next attribute of the last node. This is missing here. Something like this. Self dot node dot next is equal to none. Something like this. I don't know, but let me check this. This is okay. Let's see. Append data. It's equal. Okay. It's not equal. He is creating the node itself here. I am passing the node. Maybe it's better pass data than an object. But I believe it's not wrong. But this seems to be more clear. For example, I am passing, I am appending data, and to append the data, I create a node that called node, and I'm receiving the data. Okay, I think this is better than my solution. So if self-head is none, this is the best way. The chapter itself to check if self-head is none. So it's you can see that if not self-head, this is not readable. This is better. If self-head is none, yes. Do what? Self-head it's equal to the node. So this guy is correct. It's what I did. I believe this is the part that it traversed the code for this situation here. I'm just thinking about this now. Just for start. So I'm gonna stay here and okay, self-head is equal to node. It doesn't seem that he is creating a node inside the linked list. So let me check here. Linked list is equal to single linked list. I append 10. So if you want to see the elements in the list, okay, you need to traverse the linked list. So you start from the head. Oh, this is so boring. My God. So you start from the head and traverse this guy using okay man current data, and current is equal to okay, this is the right way. I should not be declaring this here. This is not the best way to do this. It's very as you can see, it's like it's kind of trash code. This is what it is. So now I have the linked list, create, instantiated, I append the data, and to access, let's remove the GPT idea just to help memorize and think about the problem, not just look and copy. I don't like to copy because it make us I don't know, laser and dumb. So okay, we have the linked list, and this linked list has a node, and the head is pointing to the node. Since the head is pointing to the node like this, we have access to this node, and to have access to this node, we can pointing to this node with a variable here current. We will be receiving, for example, the linked list dot head, and the linked list dot head is pointing to the node. Nice. Okay. So now we have the current, and if we print current here, we're gonna see that is the node. Yes. Now we need to traverse this, and to traverse this is while. I believe we can use while current, because what I'm saying is while this guy is true, it's not known. This guy will be keep traverse this until the end. Remember that here we have the new object. So while I have a node, I will be traversing the linked list, and when it find null, it will not traverse anymore. So this is how we can traverse, I think. And let me check now. So I want to access, so I can print current dot. Remember that current is pointing to the node, and so we can access direct the data, I think. And so suppose that now we are here and we want to go to the next guy. So we use current dot next, and we put this in the object current again. So now current that was receiving this guy is pointing to this guy, and current will be none, and this will stop. Just I believe that we just add one data, so this guy will just print one. Yes. So let me check this again. Let's add more numbers to help understand this. So let me see this. Okay, this doesn't work. Nice. As you can see here, I thought that was working. Let me see what I am missing here. Let's run again. Okay, something is missing here. Let me think about this. So one current is not known. Print current data, and current receive the next number. Okay. Oh, okay. So just remember that we don't implement this guy is this append here. We just implement this first part. So this will not work. Okay. Now let's try to implement this. This code here can be used again. And I will be putting here in this append. So when the list is empty, I'm gonna put here empty and not empty, just to be easier to record. And we're gonna do the traverse process. So let me think here. We need to tell that current it's equal to the it's equal to the node. So current is equal to the node. So while it's not none, keep traversing the data. I'm not gonna print here. I'm just gonna do I need to know, for example, that current is point to if self head is not none, it means that we have a node. This new node is gonna be inserted. How can I insert this? Okay, I can insert this before or after. This is what this guy is telling here, prepend or after. Append, not empty linked list. I think to append is just to put in the last node. So I can, so to append in a not empty linked list, I traverse the node. So current is not the node itself, it's self dot head. I'm gonna traverse. When this guy stop, it means that we are here. Something like this. We are in this region here. This is not appending into an empty list. To append in the empty list, I believe it's just in the end, you know. So how can I append something here? When this guy is new, it means that the previous guy is, I need to use this pointer from the previous guy, I guess. I'm gonna create some object here that is previous is equal to current, and current is equal to current next. What I'm saying is, when I traverse the linked list, I'm gonna use previous. Previous node to pointing to the node itself. So let me think about this. Because current is here and the previous one is here. So this guy is preview, this is current. And when I use previous, I can point this to the new element here. So this new node, this guy will be pointing to the new node. And the new node and the current. This guy should be pointing to no. I don't know how to do this. Let me think about this. Current receives self-add. Okay. Let's start to traverse this. Previous receives the current one. I'm traversing the code. Let's think about this. If I cannot understand this, I will be researching more about GPT. So let's suppose that this guy is no. So I'm traversing the linked list. When I got this, I will see that current it's looking to no, and we will stop this. Okay, so this guy is current and it's pointing to no. So instead now of pointing to no, I am gonna place another node here. And I'm gonna put current to this node. Okay. But how am I gonna pointing to no? So what I'm saying is when this is over, I'm saying that current is equal to node. But I don't know how to oh, maybe it's just current dot next. No. Or no next. I don't know. Let me check this. This is I am So let's compare with my solution here. Okay, this seems to be right. I'm starting from the head. So while current traverse to the last node. So instead of using current, if I use next, I will be stopping here. So this guy is file current dot next. If I am not doing this, I was ending here, and this is while current is telling, because now it's new. But next is telling me that the pointer is to null. Okay. That makes sense. This guy. So current next is pointing to the node, and the node itself, if it's the last node, will have the next pointing to null. Okay. This is the solution. So this was my mistake here and here, and I believe that now it's gonna work. Yes, it worked. So for today I'm gonna just be studying, I believe, that this part, the append part. So for today it's just only this. Bye bye guys, see you next